All right, and here we're going to take step by step how to solve equations. Now we're going to go one step, two step, multi-step, variables on both sides. We're going to take it one small step at a time. And first, how to solve one-step equations with rational coefficients. And that's with me, Mr. HÖEHN. Your essential question for the first section of this lesson is, what does inverse operation mean? And how do I use inverses to solve equations? All right, let's dive right in. One step at a time. One-step equations with fractions, or, as we said in our opening slide, rational coefficients. So we're going to take a look at the first example, A. That's 3/4 C is equal to 18. All right. So I have 3/4 C is equal to 18. I'm going to multiply by the reciprocal of C, which is, or 3/4, which is 4/3. Now, the reason that I multiply this way is because when I multiply with fractions, the opposite of multiplication, of course, is division. But when I divide fractions, I multiply by the reciprocal, so 4/3. Okay, and now I'm going to cross cancel. That looks like this. So I know that 3 divided by 3 is 1, and 18 divided by 3 is 6. And then I multiply straight across. 6 times 4 is 24. So C does equal 24. So with this example still on the screen, if you are doing this at home for review, I would highly suggest that you pause the video and do the same work for B, C, D, and E. I'll be here when you get back. And hopefully you're done. The equations are not solved on our screen in the video, but you can check them with a partner when you're in class with me. Okay, so what about mixed numbers? So we're looking at example F, and the way that we deal with mixed numbers is to actually make them improper fractions. And so I'm going to take the first fraction, 1 and 1/2. I'm going to multiply 2 times 1, and then add the answer to the numerator. So 2 times 1 is 2, plus 1 is 3. 3/2. The denominator will stay the same. In the same way, I take the second fraction and I'm going to do the same exact steps. I'm going to multiply the denominator times the whole number, 32, and 32 plus the numerator is 33, or 33/2. This allows me to rewrite my original equation with improper fractions, and we know how to solve this. We're going to multiply by the reciprocal, cross cancel, and I can cancel all over the place. 2 divides into 2 once, which is why I have the ones here. And 3 goes into 33 11 times. So 3 divided by 3 is 1, and 33 divided by 3 is 11. Multiplying straight across, we get 11/1, or 11. And of course, S does equal 11. And just like we did in the last slide, I'm going to encourage you guys to pause the video. No, the answers are not here on this video, but complete G, H, and I on your own. I'll be here when you unpause the video. All right, so now moving on, what about decimals? Decimals are the exact same thing, and in fact, they might actually help us underscore some of the important parts that we've been exploring so far. So for example, J. First, I have the original problem, and I'm going to divide by the coefficient, because this is being multiplied. 45 hundredths is multiplying n. The opposite of multiplication is division. That's the inverse operation. So I divide by the coefficient, and I get 7. If I were to plug that back in, of course, that does work. 45 hundredths times 7 does give us 3 and 15 hundredths. So I would again encourage you to pause the video if you're working this out at home. No, the answers aren't on the video, but go ahead and solve K, L, and M on your own. I'll be here when you get back. And we're back. Let's take a look at a real life quick application problem. So a lot of times we'll refer to a part of a whole in a percentage, and we can give a whole lot of different numbers and a whole lot of different ways to kind of explore that relationship. And one-step equations allows us to do this in a very specific way. So Latoya's softball team won 75% or 18 of its games. Define a variable, then write and solve an equation to determine the number of games the team played. All right, so I'm going to just kind of like simplify the information in the problem. So 75% or 18 games. So let's say 75% of X games is 18. So I've defined X as the number of total games that they've played. All right, so 75% of X. So of is multiplication. So I'm going to turn the 75% into a decimal. And now I have 75 hundredths times X games is 18. Well, this looks like just our previous slide and all of those examples, so I'm sure that you can guess. We're going to divide by the coefficient, and that will give us 24 total games that Latoya's softball team won. Now, why don't you pause the video and solve for the total number of games that Deshawn's team won, and that's, for example, oh, I'll be here when you get back. And we're back. So that was our exploration of one-step equations. And so I'm going to step up a little bit and start solving two-step equations. And so this extends our essential question from the last section of our exploration, and that is what does inverse operation mean? So the opposites. What's the opposite of division? What's the opposite of multiplication, or the opposite of addition, or the opposite of subtraction? And how do I use inverses to solve equations? All right, let's keep moving forward. So here's an example, example A. So this two-step equation, now the way that I like to show this to students kind of helps keep everyone organized. So if this is slightly different than what you've seen before, it will always lead you to the right answer. So let's take a look. First, I'm going to rewrite my problem. And then I'm going to circle the entire side with the variable. Now notice, I didn't just circle the 2x. I circled the 2x plus 3. That entire side got circled. What that does is it allows me to see the inverse of addition or subtraction. So here it's being added, so I subtract the 3. It's kind of like reverse order of operations. The key here is to do it in reverse order. So, PEMDAS, or parentheses, exponents, multiplication or division, addition and subtraction, tells us to do addition and subtraction last. When solving equations, reverse that order. So you see that I do the inverse of addition and subtraction first from the side that I circled. Okay, so now that's moving the 3. What I do to one side, I do to the other, so 2x is equal to 4. Of course, that means I need to have the inverse of multiplication, which is division. So I divide each side by the coefficient of x, which is in this case 2, and 4 divided by 2 is 2. So in the same way that I use the inverses in opposite order, addition and subtraction first, and circling the entire side with the variable as well, I would encourage you to pause the video and try B and C on your own. I'll be here when you get back. And we're back. So now we're going to kind of step it up a little bit again. And if you look at example D, you'll see that I have a rational coefficient for my variable. But I solve the problem in the exact same way. I'm going to rewrite my problem, and I'm going to circle the entire side with the variable. Again, it's not just the 1/4 n, it's 1/4 n minus 3. That lets me see exactly and immediately that I'm going to have to do addition and subtraction first. And so I'm going to undo that by doing the inverse of subtraction, which is addition. Add 3 to both sides. That gets me 28 is equal to 1/4 n. And of course, the inverse of multiplication is division. So I take the reciprocal of 1/4, which is 4. I'm going to multiply both sides times 4. And that gives us 112 is equal to n. So don't let the rational coefficients fool you. That's why we did the one-step equations first. Just take it one step at a time and you will get there. I encourage you to pause the video, do E and F on your own. Like you guys know, I'll be here when you get back. And we're back. So even more two-step equations. So the key thing here is seeing that I have a negative coefficient for my variable, and sometimes people don't see that. So we're going to step that one at a time. And I've got a bunch of examples here at the bottom that you can work out on your own when you've got it. Okay, cool. So I'm going to circle the entire side with a variable. So again, 6 minus 3x is my entire side with a variable, so I'm going to circle that. I'm going to do the inverse operation. Now here, a lot of people say, oh, it's subtraction. No, that's a negative 3x. So the opposite of my 6, the opposite of positive 6 is negative 6. And that's why I'm subtracting 6 from each side. Kaboom. So that gives me negative 3x is equal to 15. If you have me in the classroom, you'll hear me say things like the operation is the sign, and that's a shorthand way of remembering that when I'm subtracting a coefficient of a variable, that coefficient is negative. So I have that negative coefficient here. Solve the exact same way. The inverse of multiplication is division. And so I divide each side by negative 3. And of course, x is equal to negative 5. So again, I'm going to leave this example up on the screen. Go ahead and pause the video, work out I, J, and K on your own. And I'll be here when you get back. Boom, we're back. So now a lot of people get freaked out when they see application problems as a real world example. So guys, don't freak out. They give you the equation in there. So Chicago's lowest recorded temperature in degrees Fahrenheit is negative 27 degrees. Solve the equation. Negative 27 is equal to 1.8 C plus 32 to convert to degrees Celsius. All right. So they give us the equation, so we don't have to worry about that. But what we can do is we can now do what we've already been doing. So I'm going to circle the side with a variable. I see it's adding 32 to each side, so I subtract 32 from each side. So negative 27 minus 32 is negative 59. I have a 1.8 times C, and the inverse of multiplication is division. Divide each side by 1.8 and squadoosh. I've got negative 32.7 repeating. So I'm going to round to the nearest tenth. And so I have negative 32.8 degrees Celsius. Now, some of you are out there shouting at your computer screen or your TV screen or your phone screen and saying, hey, that should be negative 33. Well, I know, and I wasn't specific in the problem to say that we were rounding to the nearest tenth, but when in doubt, I usually round to the nearest tenth. Okay, if you have me in class, please know that I'll be specific for any test or quiz. Moving on, we've got equations with variables on both sides. Still with me, and our essential question for this section is, how does what I know about solving one-step equations help me solve equations with variables on both sides? All right, so we're getting deeper and deeper down the rabbit hole here, and for our first example, example A, you'll see that this equation has 7x on one side and 9x on the other side of the equal sign. Okay, so like how the heck am I supposed to do this? I can't circle the side with a variable. So what I'm going to do is I'm actually going to move the smaller variable, and I always move the smaller variable, not because it's a rule, but just it always is allows me a reference point so I know where to begin. So some students are like, I don't know which one to move. I could move either one. Will it give me a different answer? Just know that it'll always give you the same answer if your math is right and you're paying attention closely to detail. However, I usually move the smaller variable. Just a rule of thumb to help me remember. So of course I now have 4 is equal to 2x. The inverse of multiplication is division, so I divide each side by the coefficient of x, and 2 is my answer. Whew. A lot easier than you thought, I'm sure. Yes, and these are a little bit simple. I know you're looking at example 2 at the bottom, and you're going like, what? You can do it. I've got faith. Go ahead and pause the video. I'll be here when you get back. Work those problems out, and leave that example on the screen. All right, so I like doing this. Where did HÖEHN make a mistake? So, where did I make that mistake? Go ahead and pause the video and see if you can work out the problem on your own and see what I did differently. I'm going to quick pause and let you work it out, and then I'm going to keep on going. So pause the video here. And now that you've unpaused the video, I started by moving the constants, and that's fine. It's not a big deal. Negative 2 minus 13, a lot of times students say 13 minus 2 is 11. But both of these are the same sign. It's like you owe someone $2 and then borrow 13 more from them. That should be a 15. And so that's what gets everything mixed up, and it should not be negative 2.2. This should be negative 15, which means in the last step I would have negative 15 divided by 5, so x should be equal to, if you're saying negative 3, you've corrected my mistake. All right, let's keep on going and take a look at this amazing application problem. Okay, so the length of a flag is 3/10 of a foot less than twice its width. If the perimeter is 14.4 feet longer than the width, find the dimensions of the flag. So x is the width, and the length is 0.3 feet shorter than 2 times the width. So that gives us this equation. L is equal to 2x minus 3. Now the perimeter of a flag, now flag is a rectangle. So if I have that rectangle, the perimeter is twice the length, or the top and the bottom, and plus twice its width, or the right side and the left side. So I'm going to substitute in L. So I already know what L is, and that's going to give me a perimeter of 14.4 plus x, or and that's what they tell us here, 14.4 feet longer than the width. So now rewriting the entire equation, I know that the perimeter is 14.4x and twice the length plus twice the width. So rewriting everything and substituting in the length, which get in terms of width. So instead of saying 2 times length, I have 2 times what I know the length is. Twice the width, or 3/10 less than twice the width. And that's where this comes from. And that's why you see 2, which is I have the top and the bottom, times 2x minus 0.3, sorry, which is the length of the flag. Plus 2x is the other part of the perimeter, and equals 14.4 plus x. Awesome. Now I can start solving. So I'm going to distribute the 2. So 2 times 2 is 4x, and 2 times 0.3 is 0.6. Plus 2x, all right. Combine those terms together to get 6x. 4x plus 2x on the same side, same operation. I'm going to combine those together. And now I'm going to move the smaller x, which of course in this case is the single x, or the 1x. So I subtract that from each side. And whew, that gives me a 2-step equation. Ladies and gentlemen, I can just do the inverse of subtraction, which is addition, and then divide each side by 5. That gives me 3. So I need to find the dimensions of the flag. And of course, the length is 2 times the width minus 3/10. And that is 5.7 feet. So the dimensions of the flag are 5.7 feet on the top and the bottom, and 3 feet on either side. Woo! Oh my gosh! The application problem was rich and deep. But see, here's what you can do. Do D and E on your own. They are similar problems to the equation. A little bit simpler because they don't have the distribution, but you can do everything using this example. So go ahead and pause the video, and I'll be here when you get back. And we're back. All right. So some of this is bonus. I know that these are probably the hardest way I can present these problems to you, but I'd like to call this GCF'ing the denominators. Okay, greatest common factoring the denominators. Don't take this the wrong way, people. So the key here when I'm looking at the denominators, I don't like them, so I'm going to get rid of them. 6 is a multiple of 3. Woo! This gives me all the power in the world. I'm going to multiply everything by 6. And when I do, I see that 6 divided by 3 here is 2. So I have negative 10. The 3 cancels with the 6, leaving me with 2. So negative 10 times 2 times a. So this 2 is what happens when 6 is divided by 3. Same thing, 6 is divided by 3, giving me 2. And so now I have 5, which is the numerator, times 2 times a. That gets me 30, what's on the left-hand side. Now, what I do to one side, I do to the other. So you see I'm multiplying times 6 on the other side of the equal sign as well, but the 6's cancel, leaving me with just 35. And I can start by multiplying, and then I can combine those terms together. That gets me negative 10. And now it's kind of straightforward. The inverse of multiplication is division, and a is equal to negative 3/5. All right, cool. Pause the video. I know this is like the extra bonus, amazing, awesome, great problem. And try J on your own. Use what we did with I, knowing full well that 4 is a multiple of 2. And we're back. Okay, cool. So now let's do some multi-step equations. So how does solving 2-step equations help me understand multi-step equations? All right, let's dive in. So this looks like the multiple step here is distribution. So I'm going to actually rewrite problem and then distribute the 15. So 15 times 20 is 300, and 15 times d is 15d. Perfect. Inverse of addition is subtraction. Inverse of multiplication is division. D is equal to 8. Awesome. So now using this example, example A for this section of your notes, go ahead and pause the video and try to see if you can do B and C on your own. And as you know, I'll be here when you guys get back. Go ahead and check your work as well. You can plug those answers back into the variable. I'm going to stop talking so that you can get working. And we're back. So let's take a moment and talk about the number of solutions. So what does this mean? Okay, so when I have something like 3x plus 4 equals 3x, you can't do that because you'll end up getting, you subtract 3x from each side and you get 4 is equal to 0. That doesn't work. That's no solution. Well, all of the other equations that we have, just like the previous example A, have only one solution. I have the variable equals one single constant number. And that's what it means when it says one solution. Like here, 2x is equal to 20. Divide each side by 2, x is equal to 10. That's the only thing it could be, is only 10. So because of that, because x has one single number that it could equal, there is one solution. A lot of times the types of problems that we'll explore in class or on a quiz or a test will be one solution because we want to just reinforce the steps to solve the problem. All right, cool, or the equation. An identity, what? All right, if you look at the bottom, 4x plus 2 is equal to 4x plus 2. I'm not stuttering. It's the exact same thing. So if the same expression is equal to the same expression on both sides of the equal sign, that's an identity, which means that there are infinitely many solutions. It doesn't matter what I put in for the variable x, whatever value it has as a real number will always come out the exact same way on both sides of the equation. Awesome. So this next little bit, stop and reflect. How do you know if the solution 5 equals 0 indicates no solution, one solution, or infinitely many solutions? Go ahead and identify what that is. I'm not going to say. So now I want to see if we can check to see how many solutions each of these have. So I'm going to work out D and E with you guys. All right, let's check it out. First, I've got to rewrite the problem, and I'm going to distribute. So that's 6 times the x and 6 times negative 3, 2 times 3 and 2 times the negative 4. Combine those like terms together, and wouldn't you know, the left side, 6x minus 8, equals the right side, which is also 6x minus 8. Oh, there you go. Identity. There's an infinite number of solutions to this problem. So let's take a look at E. Rewriting the problem. I'm going to go ahead and I'm going to distribute. So 8 times 4 is 32. 8 times 2 is negative 16 here. 4 times 3 is 12. 4 times negative 5 is negative 20. I got to combine those terms together. And of course, 32 minus 16x is equal to 12 minus 16x. Okay, so here's the problem. I see this negative 16x on each side. I can cancel them out by adding 16x to each side. That gives me 32 equals 12. What? That don't work. It's a null set. There's no solution. So you can solve these without actually solving for the variable. Once you see a couple of terms on each side of the equal sign and you've combined all the like terms, it should be kind of straightforward to see if there's going to be one solution, no solution, or infinite many solutions. So go ahead and with examples D and E worked out on your screen in front of you, try F and G on your own. Yeah, I'm telegraphing. One of them is null set and the other one is identity. Pause the video and I'll be here when you get back. Boom! Application problem at the fair. Hunter brought 3 snacks and 10 ride tickets. Each ride ticket cost $1.50 less than a snack, which meant that if I subtract $1.50 from a snack, that gives me a ticket. All right, so he spent a total of $24. So 3 snacks, or 3x, plus 10 times the price for the ride tickets, which is here, gets me $24 total dollars. So I'm going to distribute, and then I'm going to combine like terms. I got a 2-step equation. The inverse of subtraction is addition, and of course the inverse of multiplication is division. So I know that the ticket cost, or snacks rather, are $3, and so tickets are $1.50. Awesome. Application problem. Guys and gals, or ladies and gentlemen, we are all those equations. We're done. That was super horrible English, but you guys are done. I will see you in class, or I will see you on my next video. And until next time, ladies and gentlemen, keep doing the math.